Hello, welcome everyone. Good morning. My name is Léa Dehaut. I'm the TYNDP product manager. Welcome to this webinar. I see more and more people are logging in at the moment, so I will give you a few more minutes to connect. While people join us, let me just introduce very quickly what we are going to do today. So this webinar is about the identification of system needs, which is a study that was conducted in previous TYNDP and that we improve with each edition. It is the first time actually that we do such a webinar or any consultation exercise on the methodology of the system needs study. So we really expect that you can help us in improving how we do this study and the results and so on. Before we start, I have to tell you that this webinar is being recorded. We will of course publish the slides and the recording later on, so you will be able to find them on the TYNDP website. Through this webinar, we will use a tool named Slido, which you may know about. Ilaria, if you can move to the next slide. If you go to the link that you will see on screen now, or use the QR code, you will be able to ask your questions, to send some comments, and also to answer some polls. So right now we will start with a first warm-up poll. So I will give you a few minutes just to give you time to get to Slido. So either with the link on the left side and then entering the code that you see here on screen, or via the QR code, which is even faster. And to check that you are with us and connected and really listening, we are going to do a warm-up quiz right now. So for this, I will leave the floor to Jean-Baptiste.
Hello, everyone. I still see the list of attendees rising very quickly, so maybe wait 1 minute. So I will be your host today. I will facilitate that workshop, so I hope that we have a fruitful exchange. Yeah, so that's great. I see some people already registering to join. So indeed, yeah, we are going to join with a quiz just to warm us up, but we will use that tool also later on to gather your views. So do register, even if you don't want to participate in a quiz right now. So welcome to everyone who just connected. We are starting this webinar with a small quiz just to warm up everyone and also to get used to a tool that we will use later on during that presentation to gather your views. So please connect to that website, slido.com, and enter the small number that is here, so 420274, and you will be able to join us. Okay, so I see people keep connecting, keep arriving here. So after that quiz, what we will be doing is to go through the plan for today's workshop. As Léa mentioned before, this is really the first time that we are doing such an exercise to have such an exchange with stakeholders publicly and widely before we actually perform the calculations So usually the TYNDP now is 10 years old. It's a quite complex document to deliver. And up until now, historically, we have always been at a point where we kind of had to rush into our calculations in order to reach the finish line. And now, as we gain maturity, I and everybody at ENTSO-E welcome the opportunity to be able to exchange more upfront and to discuss more with stakeholders about how we are going to shape the future of these studies. So that is what we are doing today. Okay, Ilaria, I see that a lot of people have connected, so maybe we can start with the first question already. Or okay. So here is a quiz on the Slido tool that you have used. No, that's not the right poll. Go back to quiz. Yes, warm up, please. Yes, so that's Michael, you are here, but that's still not the, yes. So here is the quiz. Normally you should, it should stay on screen and you will be able to answer it. So here is the first question. In 2020, the TYNDP was released by ENTSO-E, and in this TYNDP, we concluded with a big number about the investments, so the money that could be saved if we invest 3.4 billion euro a year, every year between 2025 and 2040. This would correspond to a decrease in generation cost by how much? Is it by half, so 1.7 billion euro? The same amount, 3.4 billion euro, twice 7.1 billion euro, or more or less 3 times 10 billion euros. So you can answer. Ilaria, I relate it to you to move us to the answer slide. Yes, why not the leaderboard? Let's go. So the right answer was D, 10 billion euros a year, so 3 times. Congratulations to Tomasz Simovic, who answered that in 18 seconds. And I see that the majority of you had an underestimation of the amount. So Patricia Labra, who is a member of our steering group, is going to show to you in our next presentation more conceptual side of our system needs, and she will explain to you what this number corresponds to. Probably it's not exactly euro for euro. Our study is a simple study that looks at infrastructure, that looked at infrastructure in the past. We are going to evolve in another direction, but this really gives an indication. This is a proof that there is one, at least configuration, where investing 1 euro in the grid saves 3 euros in generation costs by 2040. And that's an average of the generation cost that you would save for each year. So the benefits come quite quickly. So there was a second question in our quiz. So Ilaria, if you can go back to the quiz, actually. ENTSO-E loves putting a lot of letters. One of the combination of these letters we are going to discuss today is IOSN-SEW, IOSN-SU. About these letters, one of the affirmation only is correct. Both S stand for the world system, E stands for Europe, or you cannot form any 7 letters word with a combination of these 7 letters in English. So which is correct? And I think, Ilaria, you can go quickly to the answer for that one. Thomas is actually a very quick responder. Congratulations, Thomas. And yes, it was indeed the fact that you cannot form any 7-letter words in English. IOSN stands for Identification of System Needs. So that's what we are going to talk about today. SEW stands for Socioeconomic Welfare, which is one of our main indicators alongside environmental indicators and security of supply indicators. So socioeconomic welfare corresponds to the economic mostly benefits in our models that we see with grid configurations. So everybody is warmed up. We are going to start with the first presentation. So going through the agenda, Patricia Labra from Red Electrica, who is also a member of the steering group of the TYNDP, will give you an introduction, explain to you what are our power system needs and what they correspond to. And then Mamadou Lo and Arthur Burlin from RTE, the French TSO, are going to give us a much more deep presentation on the methodology that we propose to go to, especially with the key assumptions that we are going to take. During that time, please do not hesitate to engage with us. In the webinar tool, there is a chat which we encourage you to use. You can also raise your hand. We will give you the floor. There will be sessions for Q&A. There will also be other Slido question sessions where we will encourage you to contribute interactively to the discussion. So don't hesitate to contribute. This is why we are doing this webinar. This is really to gather views on what we are doing and insights on the direction that we should be taking. So Patricia, I give you the floor.
Thank you, Jean-Baptiste. Good morning to everyone. So let's start with these introductions. What are we talking about when we say power system needs? Well, they show borders, areas where new solutions are needed to reach the decarbonization targets and keep security under control, as the slide says. This is analyzing the identification of system needs studies, what we call usually IOSN study, that tries to answer the question of what should the electricity grid look like in 2030 and 2040 to create the maximum value for Europeans and to deliver on the climate agenda. Therefore, the objective of the identification of system needs studies to investigate where improving the electricity flow through Europe would be the most cost efficient from a pan-European perspective. Well, it's carried out by ENTSO-E every 2 years as part of the TYNDP. And in the next slide, we will see where is the EOSM process in the global 10 years network development plan TYNDP process. Well, every TYNDP starts with the scenarios definition. You will probably know that the scenarios of the TYNDP 2022 are already in public consultation, so feel free to participate. The next step is to take those scenarios to the network, to the European system, and check what are the weak points, that is, identify the needs. And the result of this study in the next release will be ready in Q2 2022. And in addition, based on the previous identification of system needs published in the 2020 release, the project promoters can propose projects that contribute to solve the identified needs and therefore to the energy transition. Deadline for this in the current process is in fact tomorrow, so take that into account. The accepted projects according to the guidelines for project inclusion in the TYNDP will be assessed and obtain a CPA between Q1 and Q3 of 2022, and the results will be published in the TYNDP 2022 release next autumn. And last, project promoters of those projects in the TYNDP portfolio can apply for the PCI level to be a project of common interest in the Q4 2022 in order to be part of the FIT PCI list of the European Commission, and therefore they can obtain benefits such as speed up permitting and political and financial support. Well, in the next slide, we can see well, the steps of the study. The ESN study allows to identify economically viable interconnections within a set scenario. And those viable links prove the existence of at least one beneficial configuration. Those needs are used then afterwards by project promoters to explore, to propose, and to justify solutions. What type of solutions? Also, the system needs study expresses, go back, please, Ilaria. Also, the system needs study expresses needs in terms of cross-border transmission capacity increase. It doesn't mean that those increases are the only solution. The identified needs can be addressed in multiple ways, including storage, hybrid offshore infrastructure, smart grids, power to gas, or perhaps other new technologies that hasn't appeared yet. So let's go to the next slide and take a look to the 2020 package. The identification of system needs study was included in the TYNDP 2020 package, and it was a set of deliverables with different uses. At pan-European level, the main report, with the name Completing the Map, a short executive summary that allows to have a global idea with the name At a Glance, and some insight reports on system dynamic and operational challenges, because both are relevant topics. At regional level, the 6 regional investment plan, as required by the regulation, that go in detail on the needs and concerns of each region, and a set of 2030 brief needs per PCI corridor to give support to decision makers involved in the PCI process. And last, some country fact sheets that go into key numbers at national level. You have all these deliverables in the TYNDP website. Yes, please go to the next. Let's see what were the results of the ESN 2020 were. Well, the analysis was focused on the national trends scenario, on that's the political one based on national reps and national plans. And it analyzed not only the 2030, but also the 2040 long-term horizon in order to be able to confirm a storyline of the system needs and check the coherence. Well, the objective of the exercise was to determine the combination of potential increase in cross-border network capacity that minimized the total system cost, both network and generation. And the exercise gave us that by 2030, Europe would need 50 additional gigas of capacity increase on around 40 borders. And on top of that, by 2040, 43 additional gigas of capacity increase on around 55 borders. Some of those needs are already covered by concrete TYNDP projects, but about 50 gigas in 2040 do not correspond to existing projects. As we said before, all options should be considered when these needs turn into projects. If you go to the next slide, well, as you know, and as we said before, we give great importance to gather stakeholders' recommendations and try to integrate them in the following exercise. During the public consultation of the TYNDP 2020, we received several comments on the identification of system needs study, and among them, I can highlight the following comments. Sorry, a minute so I can see the screen. Okay. Well, the analysis was performed on only one scenario and not in all of them. Only one climate year was used instead of a set of climate year. The 70% the methodology failed to capture the full benefits of hybrid offshore infrastructure. That is those projects that merge the their use as interconnectors and direct rest connection of offshore wind mainly. And last comment, that was an improvement of the presentation of the information. It was said that there were many reports and it was perhaps difficult for stakeholders to find the information that they needed. Okay, well, but continuous improvement is a leitmotif of these studies. This is a unique exercise in the world in a PUCA environment, and it is like a learning by doing process. So in the last USN, we included many new things from the previous one. That was the first one. For instance, the new zonal methodology. The next USN 2022 intends to improve the methodology with a 2.0 version, shaped with your help. We intends to go deeper in flexibility issues and intends to improve the data visualization. And for 2024, a mature treatment of offshore and hybrid projects intends to be incorporated. It's something that it's already been developed and tested and will be mature enough for the 2024. And also a more accurate climate data will be used for that horizon. So, well, this is my last slide to remind why we are here today. First, we would like to collect your comments to improve the methodology of the ESN. So we are so grateful of your interest. As we know, today's content is very technical. We are talking about concrete methodologies, not general framework, not results. So it can be more arid. Also, my colleagues afterwards will try to explain it in a friendly way. So thanks again for finding a slot in your agendas to connect today, to analyze the process and to contribute with your views. Second, we want to use all your previous feedback and today's comments to improve the methodology to be applied in the coming TYNDP 2022, and for those ideas more complex to implement, to set the steps for future releases, for future editions. And third, don't forget that for the next Power System Needs exercise, those results will enable project promoters to explore, to propose, and to justify solutions. Any type of solutions that contribute to the energy transition, and that those solutions can be assessed with the CBA methodology in the TYNDP 2024. So that's all. Thank you very much.
Thank you very much, Patricia. And so I don't see any contribution in the chat. So once again, don't hesitate. This being said, so as Patricia just presented to you, we are really looking forward to getting your input. And this is something that you can do right now, connecting again to slido.com. This is an informal way to collect your input. There are also more formal ways that Patricia just mentioned, and you can also contact us. So we really hope that you will be able to give us a lot of insight to shape the future. Okay, so I can see a couple of questions which I think are going mostly to, so the first one from Hannes, how do you intend to capture the offshore benefits in future studies? Maybe Patricia, you would like to answer to that directly. The second question, are there any constraints applied to the model, taking into account maximum build rates of infrastructure? Yeah, so Patricia, can you want to go ahead?
Mm-hmm. Well, as I mentioned, I don't know what you refer exactly with the offshore benefits. If you are talking about the benefits of the hybrid projects that are both interconnections and that they also gather some connections of offshore wind farms. That's what I mentioned, that the methodology is trying to be developed. It's a complex issue that it's also mentioned, in fact, in the TEN regulation, that many things need to be considered, also spatial planning and other topics. So, well, it's by now it's being developed, and we intend to include something in the next release, but more probably will be included in the 2024 one. Regarding the other question, I didn't get it, Jean-Baptiste.
Yeah, they are displayed on screen if you have the screen. The next question was about the constraints applied to the model. If we apply maximum build rates of infrastructure.
Sorry, maximum build rates for the infrastructure. Well,
yeah. So essentially, I understand the question is: do we put into our model limitations? For instance, we know that it is difficult to build this infrastructure. We know that there may even be limitations in terms of the raw material procurement. So, do we put that into account into our study? Do we take that into account?
Okay, sure. So probably my colleagues will tell some details later, but in the candidate projects that we consider, the candidate capacity increases that we consider, they have a cost that considers all factors, and also some complexity issues that make perhaps that capacity increase more complex, and of course then it's more difficult to be included by the model as a selected capacity increase. So, well, that's somehow considered.
Okay, I see a number of questions which are actually going to be addressed in the next presentation. So maybe we will keep them for after the next presentation. One is about the reference scenario. So for which, I mean, the answer is quick, yes, we are going to use the same reference scenario, but my colleagues will give you more details about that. And actually, we do have questions about that for you too. There are also questions about the flexibility of the power system analysis. So how we are going to improve that. Looking at flexibility, this is also something we are going to address specifically. It's really one of the main efforts. It's probably the main dimension of what we call our system needs 2.0. What will be the CBA approach based on lines only, or consider cable stations PFC? Where do timelines for this come from? So the cost benefit analysis, which is another element of the TYNDP, this part of the exercise, it takes into account only candidates. So we at ENTSO-E, we don't design, we don't create conceptual project for the cost benefit analysis. We wait for promoters to send us projects. They have different levels of maturity. Some of them are nearing construction. Some of them are very early in their conception, and depending on the maturity of project, you have more and more precise view of the different technical elements that are going to comprise it. But we do assess projects that are like complete projects, including the substations and all the technical elements. One question for you, Patricia, which is related to your presentation. The timeline shows that the CBA assessment starts already in Q1 2022, and that's accurate. Our teams are actually really already getting prepared and getting the models prepared, getting organized. The question is, because it starts before the end of the system needs analysis, what is the expected impact of the system needs process on the CBA assessment?
Well, as I explained in the timeline, the call for projects for the next CBA that ends tomorrow, in fact, is based on how in the previous identification of system needs, the one done in the 2020 release. So with the scenarios and after the public consultation of those scenarios, we can start the CBA on the projects that we collect this autumn, and the identification of system needs goes in parallel and will serve as a basis for the TYNDP 2024. But I see a lot of questions of the audience, so I'm happy that there is a lot of interest on the topic. Probably some of the issues will be addressed in the next slides.
Yes, thank you very much, Patricia, for your answers and for that contribution. I can see another question, for instance, on ancillary services and the specific indicators. So let's keep that for the next session. One question, the opportunities of system integration and sector coupling in the study. So how do we deal with that? I don't know, Patricia, if you still have time to answer to that one.
Yeah, but I think that we will see something later in the slides afterwards, because of course it's something that perhaps is new, and we are trying to incorporate in the process as candidate projects. So I think that it will be better to comment it later, because electrolyzers can be also candidates in this new process. So well, let's. I think it will be better to see that. And afterwards, perhaps go back to the question.
Yes, let's do it this way. I see one more question on the time slides. So maybe Ilaria, you can go back to that one. Thank you. About the dates that you see here. So there is a question if the years are accurate, and yes, they are. So right now we are at stage 3. So we are in Q3, Q4 2021. We are delivering the project collection. We actually started the scenarios. So the stage 1 is going for consultation now. So yeah, I mean, I can see with this slide that actually the numbers are really representing the concept of how the TYNDP is organized and goes from one element to the next. The dates that are shown are mostly for release and for consultation. So sometimes they are intertwined in a different way. And so the first part, the scenarios just went for consultation very recently, 2 weeks ago. And the identification of needs, we are speaking about the methodology now, and we will do the calculations early next year. The project collection is already here. So yes, in the concept, the project collection should come after the identification of needs. This being said, we really believe that our studies are mature studies, and the last time we did the identification of needs was less than 2 years ago. So it serves to inform the stage 3, which is right now. we will perform the cost-benefit analysis once we have reviewed all of the candidate projects through 2022 to feed the PCI process that the European Commission will lead in 2022. So I think now we should move to our Slido part because we have an agenda to respect. We'll review the rest of the questions also after, so we are sure to address everyone. During that next stage, we really ask you to trigger also interesting conversation, maybe even within stakeholders and for us as well. So you can use the word cloud to answer our request. The first one is, do you use TYNDP system needs results? So are they useful for you and for what purpose? I would add, even if you don't use them today, what would you like to use them for? So that's really a question about use. Go ahead. And I assume we should see the cloud starting to form as we speak. No, don't log voting. Yeah. No, you should. So some answers are going to appear. It's good that the first one is really the main target that we have, identify where new projects could help. That's why we are doing that exercise. Unfortunately, my Portuguese is not good enough, but if someone wants to jump in, go ahead. So SEW overview, market trends to see the gap in energy transition, scenarios of possible developments of the grid. So you use them to see that. TYNDP 2022 project sustainability. So up for own scenarios and study, identify where new projects could help, market couplings. So TYNDP 2022 project suitability. So that is really looking at the question from the other side than the one we presented. Looking at if all of the projects that are in the TYNDP together are viable. Individually, this is done by the next stage of the TYNDP, the cost-benefit analysis. This is a stage where we look at if projects actually deliver benefits to the grid. The system needs normally is not designed to do that. The system needs is designed to check if there are areas where you could fill gaps. You could also possibly find with the system needs areas where you have too many developments, but you normally should also see that with the cost-benefit analysis. The system needs can help you, this being said, to actually put the right scale on your cost-benefit analysis. So especially in regions where you have too many projects, it can help us to figure out what would be an appropriate baseline to analyze this project. So to check the impact of adding extra capacity, so I'm happy to see that actually everything is what we also think that people use it for. So getting an overview of a flow in Europe. So difficult to use as only one scenario presented. So thank you for that comment. So we'll also give you the opportunity to voice it in the next. So maybe we can move to the next question. So after the question about how you use the system needs result, let's guide us a little bit about how we should improve. So what are the most useful direction? So I can only see 5 of the answers on screen. I think there are some more below, so please go down as I speak. So should we use multiple scenarios? One of you already said that in the previous questions. Multiple climate years, we've only used one. Yeah, things are going to appear as they say. So identify storage and other flexibility needs for now is on the lead. You also have other options that I haven't mentioned, improving the identification of offshore need, improving the way we present results as well, improving the modeling or actually changing the modeling. So the question here is a bit technical. You will know more from the next presentation. But I can see that for now, people tend to gather around mostly the identification of storage and other flexibility needs. So once again, good news. That's also what we have identified as a big area of progression. The multiple scenarios as well. It seems to be a strong recommendation. Okay, I think the results start to stabilize, so maybe we can already move to the next question. And so the outputs, so what do you want to see? So differently to what do you use, this is really what do you need as outputs? Do you think that we should get capacity increases for transmission lines? Do you think that we should get other indicators, that we should get money saved, CO2 saved? How should we present these results? And what is useful for you? So go ahead, that is a bit more specific than the previous 2 questions. Okay, CO2 saved, how much storage is needed? Capacity increase. So while the answers keep popping, I want to react on the CO2 saved one. Of course, it's something that all concerns us. It's very important. It's not at all easy to do, much less easy than it could sound to someone who has not given a bit of a deeper dive into modeling and how we get indicators. Why is it not easy? Because you take a scenario and whatever way you want to design your study, for now, what we are doing is that we add capacity and then we remove capacity and we see what is happening. But in real life, that is not what's happening. In real life, the interconnection project or any other structural project on the system, be it bringing more flexibility, are going to enable more transformation. So if we put a line that connects to a region that can provide a lot of offshore, that's a big offshore potential, then it creates a possibility to create more offshore parks. But of course, the CO2 savings are not all attributable to the power line. They are also attributable to the offshore park. And these are the sort of questions that we have to wonder, that we exchange with regulators, with policymakers, with others to find what is the right balance, because I mean, it's as much as it would be unfair to put all the CO2 savings of the decarbonization for the grid. The grid are really an enabler, and as such are a very specific element. So about what you told us, you need so a lot of mentions of capacity, of different benefits, some quite specific technology questions like power to gas assessment or storage. Flexibility needs, that is also something that's so beyond integrating flexibility into our study. We also look at that on the side. What new challenges also for the system stability are going to be there. Okay, so I see a quite big list of recommendations. I hope that we also get them in a more formal way during our consultation. And now I think will be the time for the next part of our presentation. So I will give the floor to my colleagues. So Mamadou Lo and Arthur Burlin are going to give you the presentation on the methodology itself. So now it's going to get a bit more technical. Also, don't hesitate to ask questions using the Slido tool. We will check them afterwards. And if we don't have the time to answer every question today during that webinar, we will answer them directly with you afterwards.
Thank you very much, Jean-Baptiste. Hello, everyone. My name is Mamadou Lo. I have been working for RTE since 2015 as a grid development analyst in the long-term system planning department. My activities at ENTSO-E started with TYNDP 2020 study team, especially the Aeration process in 2030 and 2040. And also I am support in the implementation of zonal modeling during our Aeration. So I will let my colleague Arthur introduce himself before going on with the presentation. Please, Arthur.
Thank you, Mamadou. Hello, everyone. So my name is Arthur Berlin. I'm also working at RTE as a market modeler. RTE being the French TSO, and I'm currently in the TYNDP study team, and mostly contributing on the IOSN and especially the IOSN 2040.
Perfect, thank you. Please, Ilaria, could you put the presentation on full screen, please? Thank you very much. So for the next slide, normally there is the agenda of the. So we are going to start with reminding what identification of system needs stands for. We will also give the global presentation of the Aeration process, and also present in the third point what are the innovation included in this version of the Aeration, the assumptions and the methodology before going on the Q&A session also. So what is identification of system needs? What are the grid flexibility and flexibility reinforcements needs for the European power system? In fact, system needs identify grid and flexibility reinforcements in Europe in order to create a maximum value for Europeans. The maximum value will be obtained by reducing the system cost, the global system cost for European community, not TSOs, not project promoters, but the European community. And also in order to ensure continuous access to electricity throughout Europe and deliver on the climate agenda. So the climate agenda, we mean by that point that the needs are identified are extremely linked to the dispatch and the philosophy of the scenario which is studied in order, for example, to manage the system decarbonation in the time horizons we study. The second point, to say that system needs gives a broad vision of flexibility development opportunities for two time horizons, 2030 and 2040, in order to have the opportunity to build a path of developing the energy system between those two time horizons. And also the optimization is mutual, so we have a co-optimization not project per project, not border per border, but everything on the same time is analyzed in order to consider mutual influences between different investment opportunities, which can be transmission candidates or flexibilities, etc., etc. So the details of all these points will be given further in this presentation. In the next slide, this is an illustration of the co-optimization. We go from a starting point, which is the base case of the study. To this starting point, we give some investment candidates, which can be interconnectors and flexibilities. For each candidate is defined by its cost per megawatt per megawatt and its total capacity. And also, we put everything on an optimizer. We use Antares simulator in order to optimize the system cost by minimizing the total operational cost and the investment cost. And the result of this process is an optimal power system in which we have the different candidates which are invested on, and the one which have not been selected by the optimizer. For example, in the result here, we can see the interconnector one is invested in, and the second one is not included, and same for the flexibilities. Some details in the next slide about the tool we use. So we use the investment optimization tool linked with Antares simulator. Antares is a Monte Carlo software for power system analysis. So it is one of the 7 ones used in ENTSO-E in this TYNDP CDA process. But here in Aeration, we only use Antares because the optimization tool we need is only available on Antares for now. Antares is designed to perform generation load balancing studies, so also adequacy. It can perform economic assessments of generation and transmission projects by simulating the operation of large interconnected system with a time span of one year and time resolution of 1 hour. Even if it is 1 year in the optimization, in the simulation, we in the Aeration, we study several climate years, and this point will be also detailed further in the presentation. Antares is developed by RTE. It is open source for now, and the expansion module to be used will be used in this study. It was also used in the previous TYNDP, and it had the power of being able to minimize the investment and operational cost in order to suggest an economically optimized portfolio of the whole European project. So in the next slide, we give an overview of the Aeration process. So the process is globally the same for 2030 and 2040. We will show what are the differences. So the first step is to establish the starting point, which is the base case for each time horizon. It considers the starting grid entities defined in the reference grid. On the other side, we take into account the PMIMDB at the time horizon for other countries. In this Aeration scenario, national trend is studied for Aeration, as Jean-Baptiste reminded it earlier. With all this data, a market study is built, either MTC market study for 2040, for example, time horizon, or zonal market study for 2030 time horizon. And we go to the second point, the second step, which is the investment loop. How do we do that? The starting point, which is the base case, is put into Antares simulator expansion optimizer. On the one hand, as input, interconnection candidates are given to the optimizer. They are prepared on the specific data collection in order to give to the optimizer candidates on the borders. This is the case for 2030 and 2040. So we use interconnection candidates for these 2 time horizons. The only difference is that for 2030, we also have to identify the interzones as we use a zonal model. On the other hand, and only for 2040, flexibility candidates are also given to the optimizer. The reason for that and the details about the candidates will be given further in this presentation by Arthur. With all these parameters, the optimizer will identify the total needs in megawatts in the scenario for the time horizon for each border in order to minimize the total system cost. In the next slide, we present briefly what are the differences between the two models we use. So the first one is NTC model and the second one is zonal model. So those two models are used to build market studies. So let's focus on the different two models for them 2030 and 2040 and discuss the differences. For 2040, a classical NTC market model is used for the study. It is built with one node per country. So you can see it in the first table. For an NTC model, we have one node per country. Between cross borders, we have NTC values which are activated, and there is no binding constraints modeled. That means the different zones are copper plates which are connected by HVDCs. So for 2030, it's a zonal model which is used. Countries, at least some of them, are divided into several ones. The capacities between zones are no longer NTCs, but equivalent capacities, which are calculated for the interzones. However, they are only activated for cross borders and not internally in countries in the methodology we use. Also, there are binding constraints which are added into the model in order to take into account Kirchhoff mesh rules. It is the case for all the interzones, not solely cross borders. That way, the different zones are copper plates connected by AC grid or DC for some specific boundaries, like borders between UK and other countries. So what also you can see is that when we go from an NTC model to a zonal model, we will improve the accuracy of flow calculations because we take into account the Kirchhoff mesh rules. And on the other hand, when we go from a zonal model to an NTC model, we will have more robustness in generation and load assumptions because we will use the country level hypotheses which are more precise. So the two models do not have the same characteristics. The zonal model is evidently more complex to build and handle, but it has advantages of considering grid parameters into market study, which is very relevant. And with the example given below on the left, we can see the impact of a zonal model on the flows. For an NTC model in which every line is limited to 1 gigawatt, for example, and with the generation which is represented in the example, each line will be loaded at the same rate because it's NTCs, so it's HVDCs. We define the value, so the value would be 1 gigawatt for each line. On the other hand, on the right, you can see that in a zonal model, as there are the Kirchhoff mesh rules, the line AD would be less impedant than AB plus BD. So the flow on AD in a real grid would be equal to 1.5 gigawatt, while only 0.55 gigawatt would go through AB and BD. So by including the mesh rules in the model, as it would happen in real life, the market tool would have to adapt its generation in order to preemptively avoid the overload on AC. So that is the added value of a zonal approach. And what we can say for these two models, even if they are different, they're differently used in these two time horizons we study in Aeration. The needs will be identified cross-border per cross-border and not, for example, interzone per interzone. And the challenges of the scenario, which are defined in the beginning of the study, in order to know how much, for example, spillage we can capture, reduction we can capture, those challenges will be identified with a copper plate simulation, no matter the model or which model is used, and this is compliant with each time horizon. Third point, the same methodology, so the same software tool, so expansion module will be used for the two time horizons, except that the investment candidate types are not the same. And the last point to say that the same interconnection candidates will be used for both 2030 and 2040 time horizon. So even if the models are different, the outputs will be standardized. So now I think I will give the floor to Arthur in order to go further in detail about the assumptions and the methodologies we use, for example, in expansion. Arthur, please.
Thank you, Mamadou, for all that. We can go to the next slide. Perfect. Well, now that I hope you've all got the grasp of the IUSN and what we're trying to do in the identification of system needs, I'd like to go further into the key assumptions and in particular the improvements that we've introduced in this IUSN compared to what was done in TYNDP 2020. And I would like to start this with investment candidates. So investment candidates are our flexibility portfolio that the optimizer can invest in order to reduce operational cost for the system in its optimization. And well, interconnectors are a good way to reach decarbonization targets and meet security needs, but they are not the only flexibility available for that. And this is why we wanted to capture more projects, more possibilities and more opportunities in our IUSN by introducing storage flexibilities and peaking flexibilities. Peaking flexibilities being the means needed for adequacy during peak hours. So this is new in IUSN 2040, the NTC model in the IUSN of the TYNDP 2022. It will not be the case in IUSN 2030 as the zonal model, as you might have understood from the previous slide, is more complex and therefore adding additional complexity, including a lot of new candidates, significantly increases computation time, and even the optimizer cannot manage an optimization with too much complexity. So this is why we are introducing storage flexibility and peaking flexibilities in IUSN 2040 in the NTC model. I'd like to say a few more words about those flexibilities in IUSN 2040. There are a lot of different flexible technologies, and facing an operational constraint, complexity constraint, we've decided to separate those flexibilities into two categories, being storage flexibilities and peaking flexibilities. For those two flexibilities, the cost assumptions and the modeling assumptions that we will take is in line with what is done in the TYNDP 2022 draft scenarios that are available. For batteries, for storage, we would like to cover the hydro pumping needs and the battery storage investment needs. And for peaking, we've decided to go with carbon-free solutions to cover the needs in a peaking flexibility solution, peaking flexibilities. So to sum up, the expected outputs of our IUSN, and especially here of our IUSN 2040, is to have an idea of the borders and areas where we might need interconnections, but also storage and peaking flexibilities needed. We can now move on to the next slide. And well, as Mamadou said, Antares is a tool that allows to survey large number of load and generation patterns. And this is possible through using multiple climate years in our studies, meaning different climate conditions, wind, temperature, cloud cover, which will then impact the adequacy in the electric system through wind production, solar production, hydro inflows, demand. And this is why within the TYNDP 2022 process, we wanted to cover more more situations, more climate situations, and do so by using more climate years. I'll stick to what I said earlier, the NTC model being less complex, and it's interesting here it's possible here to introduce more climate years, or at least we're going to try to. And there was here an equilibrium to find between using a wider range of situations and the computation time for our optimizer. And we chose to use 10 climatic years for IUSN 2014 NTC model. Unfortunately, this is not that simple for IUSN 2030 for the zonal model, which is way more complex. And therefore, we are sticking to 1 climatic years for IUSN 2030. And if all goes well with 1 climatic years, in terms of computation time and operational feasibility, we will go and we will try to use 3 climatic years for this IUSN, which would be also a major improvement. We can now move on to the next slide to talk about another improvement of the TYNDP 2022. And this concerns the IUSN 2030 and the zonal model. In the TYNDP 2020, the clustering approach to determine the zones of the zonal model was based on administrative boundaries for the zone definition. However, well, it was stressed out that this methodology needed improvement and needed to stick more to power system characteristics. And so ENTSO-E is currently working on this point in improving the clustering approach. And the idea would be not to base ourselves on administrative region boundaries, but on network contingencies in the ENTSO-E network. So there is, as I said, ongoing work on the matter. And the idea would be for the TYNDP 2022 zonal model to update our zones to fit more to network contingencies. For this IUSN, we've decided to go through a 2-step optimization process. So this is the chosen approach. The idea is to have an optimization. Well, there are relevant existing flexibility projects that can cover part of the needs, but not all the needs, and not all are relevant. This is why these needs to be completed with conceptual ideas, projects in order to reach the system needs. And this is our 2-step approach, saying that we will have a realistic vision of the system needs by investing in relevant or foreseen existing projects in order to cover part of the needs. Those would be grid and flexibility projects, and those will be completed by conceptual projects of how the needs might be met to complete and reach the global economic optimum in the IUSN. So, to sum up the TYNDP 2022 IUSN methodology improvements regarding to what was done in the TYNDP 2020, we would like first a wider range of climatic situations, and this will go through more climatic years in IUSN 2040 and eventually, hopefully, in IUSN 2030. It will go. We will also have more candidates by introducing flexibilities in IUSN 2040, a less complex model which will enable us to do so. And we will update the clustering of the zonal model to have clustering based on the network contingencies, and so more fit for the study we're trying to launch. Having said all that, there is one subject that's missing. It's the offshore hybrid offshore project. So as Beatrice has said, the methodology previously employed in the TYNDP 2020 is not fit to recognize the hybrid offshore infrastructures, which are particular. The idea of hybrid offshore is to link a wind farm through an interconnector to two countries. So the cable will be used for wind energy injection on the grid, but also for cross-border exchanges. And those projects are a little particular. And there is a plan to introduce them in the need study, but not this year, because we're currently driving a pilot study in order to set the correct methodology in order to assess those hybrid projects and identify the needs in such infrastructures, unlike it was done in the TYNDP 2020. And so if the study ongoing currently in ENTSO-E is proven to work, and well, we will implement this approach in the TYNDP 2024. In terms of timeline, where are we? Well, as I said, we're currently updating the zonal clustering within ENTSO-E, and we're also running tests on the operational feasibility of the methodology that we've just presented to you. This will take the time it takes, and then it will enable us to, well, build the zonal model and more. Of course, launch the studies and analyze the results, and the objective would be to publish those results to you at Q2 or Q3 of 2022 for the system needs study. Thank you for listening, and well, should you have any questions, please ask.
Thank you very much for your contribution. So we do see a lot of questions popping up, so we are going to put them back on screen. We are also started answering them actually during the presentation. So I will repeat some of the questions that I see popping on screen. There are 35 questions already. We are really happy to get such a live audience, and we will answer to each of these questions, not maybe to all of them live. I'll start with the first one. How do you choose the zones for each country? So maybe you can explain a little bit better. And the zones, I guess it's for the zonal model, but maybe a good opportunity to speak about the zones of the climate database, for instance, and how we actually related to that.
Thank you, Jean-Baptiste. About the zones, here we will only discuss the zonal model, so the zones we use in the 2030 Aeration process. How do you choose them? In the previous TYNDP, we established clustering that was used, which were based on administrative boundaries. So this one was used, so we know it was not perfect. There were some remarks about improving them, because in some countries we didn't have the best quality we wanted to have. So the idea for this TYNDP is to try to see if we can do that before really beginning the building of the zonal model. So that is the reason why the study is still ongoing. And the different criteria we use in order to choose the zones. There are several ones, and because there is no perfect clustering, because the perfect clustering would be the one with one node per zone, and that is not realistic. So we have to find the best compromise between several criteria. For example, which lines we will put on the equivalent links, the limiting elements we choose, the number of zones, in order to have a model which will converge when we will run it, the quality of the reduction grid, because the more we split countries, for example, maybe the better, but we need also to limit the number of zones, etc., the capacities we obtain after clustering, etc. So there are several criteria. We need to find the best clustering which will fit all these criteria. So there are some choices which we need to make, and this is an iterative process. And the idea is to work with all the TSOs, etc., in order to establish the best clustering possible.
Thank you, Mamadou, for this answer. I liked very much the quote from George Box, a famous statistician: all models are wrong, some models are useful. Obviously, we cannot represent reality, and what Mamadou described is our constant struggle to find what is the appropriate level of detailing. If you go too much with too many data points, you are actually not going to improve the quality of what you look at. You are going to increase its complexity and maybe actually get further away from what you wanted to see. So it's a complex balance in creating the model. So don't hesitate also to go and check other people's questions and to vote. You see that there are little thumbs on the side. We are going to take the most popular questions. They are appearing on screen entirely unfiltered. So the more you vote for questions, the more likely it is that we are going to take them. And I see that the next question is rapidly taking votes. So what will be the improvement in the system needs methodology to capture the full benefits for a connection between European countries and third parties? So here we mentioned Tunisia, Italy. Obviously, there is a new third-party country, the UK, which had a lot of interconnections and which is very strategically located for the development of the electricity grid in Europe. So let's put the elephant in the room in the middle as well. But these questions, of course, is one that we have also worked on for a long time with the Mediterranean region. So Mamadou, if you want to take it again, or Arthur.
About which question?
Third countries, yeah.
Third countries. Oh, third countries. Normally the project which are selected are the PCI ones. So when they are PCI, they are taken into account in the candidates, and if not, they are not included. And I have seen another question about.
There was the question, Mamadou, sorry, was about how we improve the calculation of benefits, so how we capture benefits for the system needs in terms of interconnection with non-European countries. So maybe the question was more about these models.
There is no specific task on this. If the project is PCI and it is selected, it is treated exactly as the same as the project which are in the European area. So all the candidates are included in the optimizer in the same way.
Yeah, beyond that, we do actually have a work stream and we work with MedTSO in particular to increase improve the way we model the countries of North Africa. The ENTSO-E zone is way beyond the EU. So we do already look at all the Balkans and so the neighboring systems are being worked on. The next question is, what if one given interconnection candidate is selected by the optimizer in 2030, but not in 2040? So yeah, indeed we have two separate steps for optimization. So what happens when something is not confirmed in 2040?
I can talk about what we have done in the previous one, and maybe Arthur will complete with his vision. Of course, this is a very good question. This is some point which we analyze also in our studies, because the idea would be that if a need is selected in 2030, normally as the scenario are increasing between the two time horizons, the same need would be normally selected by the optimizer in the 2040. But this is an automatic optimization, so we cannot control what is the output. So sometimes it can happen. In the previous TYNDP, we did have the case on, if I remember well, 4 borders. And for those 4 borders, for those 4 candidates, we have done deeper analysis in order to see what could be the reason why the project was no longer selected in 2040. And we have, for example, seen that in some borders, the optimizer didn't select it in the optimal solution, but we have tested also the upper bound needs in every border. When, for example, we say to the optimizer, what would be your solution if the system cost was not reduced by the maximum, but if, for example, the system cost was 10 million higher, for example, what would be your solution? And these are the solutions which we found, for example, included these 4 candidates. So sometimes it's just that given that it is an optimization, the optimum could be very flat. So when you disoptimize a bit the calculation, you can find another solution which is very close. So in the previous TYNDP, if I remember well, there were only in 2 borders in which we did finally have the case. And for those 2 borders, there were single pint calculation which were made in order to see what is the specific impact of each candidate. And unfortunately, we have seen that for these 2 borders, for these 2 candidates, the benefit was not enough in order to be selected by the optimization, because, for example, these 2 projects were too expensive in order to fit the benefits we obtained in 2030 and also in 2040.
And so, very importantly, I think that beyond this technical explanation of what happened in the model, it really goes back to the concept. We are not doing a study to find the optimal solution. The optimal solution does not exist because it also, it's not something that ENTSO-E should be doing. There are technologies that are going to evolve. If you speak only about the transmission lines, there is a reality of where it's actually possible, feasible to implement the infrastructure. And beyond these transmission lines, obviously the needs that we look at can be addressed by other non-wires solutions, including, of course, storage or other ways to bring the flexibility. So it is normal that when we look at 2 different scenarios, we can find 2 different optimal configurations, but which are just one example of an optimal configuration. So if you change the scenario, they are not going to be sequential and come one after the next. It's maybe something that is a little bit non-directly apprehendable when we look at our study, but this is really the concept. We are not looking for what to do. We are looking to prove that there are areas where further work is needed to identify what to do. Okay, so the next question, do you intend to implement flow-based market coupling into your model in the future? So Mamadou, that's really a question for you.
I could say no, because we don't know how to run it. We don't know if it is doable. And the zonal model is another way to include grid criteria into a market study. So for now, and this one has been proven during a specific task force, etc., before being used in the TYNDP. So for now, we only have that, and the flow-based we are not intending for now, but we don't know what will happen in the future.
Thank you. So one question which I skipped, the flexibility of all storage and pump storage power plants considered. So I think the keyword in that question is all. So how do we consider the flexibility of storage and pump storage power plants?
Yeah, I'm sorry, I'm not sure I understand the question exactly. Maybe if, Mark, you could clear a little what you mean by flexibility of all storage considered.
Yes, maybe Mark, if you want to actually speak directly, I'm going to try to find you and unmute you.
Yes, thank you. So the question was related to hydro storage and hydro pump storage power plants. We have a lot of those in Switzerland, and they are included in the model for 2040. And is the flexibility of all these power plants considered?
Okay, thank you. Well, yeah, all means that are modeled already in the model are flexibilities, and the way they are modeled, the way they're taken into account, all storage power plants are considered with their flexibility. And the IOSN introduces more flexibility candidates, which are independent and additional to what already exists in the model. I hope that answers your question.
Okay, I see the next question, which I will answer myself. It's about the 70% rule of the clean energy package. So that's an important one, the one that say that 70% of all interconnection must be reserved for the market. How do we take it into account into our study? That is a very good question, and that is a question for which we don't think there is sufficient maturity or alignment of views. So for now, we don't take it into account. In the slide of Patricia presented earlier, we know that it is a request by stakeholders. We have been discussing it with regulators and with other parties as well. So there have been work streams to address that questions. But for now, there is no consensus, or it's not mature enough. We wouldn't know how to actually consider it into our model. So the answer is that we don't. The next question, will the next system needs for the 2022 TYNDP take into account more scenarios, so all three scenarios? If so, will we see three different optimized power systems configurations?
Thank you for the question. Well, no, we're not planning to take into account all three scenarios. The IOSN for the 2022 TYNDP will be based only on national trends, and which answers the second question.
Yes, I want to point out that the way we do scenarios is very, very important as well. The central scenario, which we call national trend, is what we call a bottom-up scenario, which means that we take data that comes from member states and we bring them together with a set of rules and methodologies to create one scenario. The other two scenarios, which are mentioned here, the E and GA, distributed energy and global ambition, they are top-down scenarios where we design the objectives of the scenarios and we run optimization engines, models, softwares that create the scenarios based on what we have told the software to do. And as such, actually, you can also consider that these scenarios become somehow system needs. So we don't present them this way, but you can actually also from these scenarios analyze the system needs gaps because of the way that they are built. So they are very, very different, and that is the main reason why we perform this analysis mostly on the central scenario. So do you consider SSSCs for digital power flow control as part of the flexibility solution? So SSSCs, maybe, I know that we are using a lot of acronyms. I'm not familiar with that particular one.
Static synchronous, series compensators, and those one. Those one we have, we use only PSTs in the model, but as a candidate, as solution for ISN, no, we don't use that kind of a solution. And the candidates are given during the collection window by TSOs and project promoters. So we didn't receive something on that test, if you remember well.
That would be hard to implement in a NTC model, which actually in which we study flexibility solutions.
Okay, thank you for this answer. I'm going to go to the next question. How to evaluate the benefits of each investment, so of one interconnection, for example, if they are all doing at the same time with a co-optimization? So thank you for that question. I'm going to answer it myself too, replacing Patricia, who had to leave us. So this actually is a question that regards the concept of the TYNDP. The assessment of each interconnector, of each element, is made during the cost-benefit analysis stage. During that stage, we run an analysis and we deliver a project sheet for each project. You have quite detailed information about the project, as detailed as we can get, and you get assessment results for each of the project. And that is what you should be looking at if you want to know what is the impact of one single element in the system. In the system needs, on the other hand, we are not looking at the specific impacts of each element. We are looking to prove that there exists a world in which investing into the system is going to bring benefits for Europeans, and by doing so, to point to where are the most likely areas to get these benefits, so where we should explore more solutions. But it's very important, very, very important to understand that the system needs are not an assessment of transmission solution. So now we are adding flexibility, but even when we didn't, it's not the case. The system needs, the results can really, the need that we find can be addressed by any solution, and also non-wire solution. It is really now a very well-established position at ENTSO-E, and that I think is shared with all stakeholders, that we need to put all of these solutions together. So we are definitely not looking only at wires. If you want to do that, you go to the cost-benefit analysis part. Will you publish the methodology how climate years are chosen? So Mamadou, back to you, or Arthur, of course.
Yeah, it's a methodology used in the binding zone, validated by Aeration. So I think it's already published, or yeah, but it's a public methodology.
Yeah, so we are going to communicate that. The next question by Mark Howitt actually is not a question, it's an observation. Mark observes that regulation makes the best project impossible. Connecting large renewables to grid through large-scale, long-duration inertial storage contracts impossible. So, Mark, I don't know if you would like to take the floor to develop a little bit, but that's not, I mean, something ENTSO-E is in charge of, the regulatory part. Then I will take actually the next question, which is also by Mark. So 2030 is too short term. Grid connecting project often take this long just to be financed, planned, and built. Must focus in longer term. Yes, so that is something that we agree with Mark. We understand that there is an interest for the 2030 time horizon, especially by policymakers, by regulators, by investors, who want to make sure that the direction that we have taken and the investment that are ongoing correspond to actual benefits from Europe. So once again, this phase should not be confused with the stage of the cost-benefit analysis, where you look at benefits for each project, but it's still important, and especially the TYNDP is used as an input for the project of common interest process led by the European Commission, and which currently focuses on the year 2030. This being said, we agree with you. System developers need more time. Project promoters need more time to get their projects done. 30 plus is a very long time horizon, but indeed, we consider that the 2040 time horizon is more likely to provide information to project promoters that would want to identify where the next solutions are needed. We have also considered the possibility to go beyond 2040, but of course, the further you go into the future, the more difficult it is to decide what you are going to represent into your system, and the more uncertain the models would become. The level of uncertainty that we would face for 2050 and beyond, for us, make that the study is simply too expensive to deliver. We would have way too much work to do in order to try to have a proper representation of 2050 that would need more than one scenario. So we simply cannot have a central scenario beyond our models that we think would be accurate enough. So there is a follow-up question to the question about the Italy-Tunisia project. So because the Italy-Tunisia project is not a PCI, it is ignored from the system needs calculations, is a question from Simon Ludlam.
Yes. Yeah, okay. Do you want to go, Mamadou? Or...
Go ahead.
Okay, well, the scope, the geographical scope of the IOSN is the ENTSO-E countries and not MED-TSO, but we do have in our models non-ENTSO-E countries models, but this is only for projects which are PCI. So if the project was not a PCI, then it would not be included as a project in the IOSN.
Okay, the next question, how do we deal with the opportunity of system integration, sector coupling in the study?
Well, this is more of a scenario question rather than a system needs question. And it's well taken into account into the scenarios, distributed energy and global ambition. And it is not part of the IOSN study to deal with a sector coupling.
Yes, well, the sector coupling is also taken into account, of course, in the national trend scenario. So it's bottom up and not created from the top. In the two other scenarios which were just mentioned, we are able to design how much sector coupling or system integration we want to see. But yes, so the answer to that question as to any other future technology or the development of renewables and so on, it comes from the scenario. So we build a scenario which we think with stakeholders is what will, what we have a likeliness to achieve by 2030, 2040, and which represents a good basis to test our infrastructure. Will you assess the impact of more interconnections on generators' profitability? This is also, I think, mostly a scenario question, but nevertheless, Mamadou, you can try to answer it.
Well, I would say that benefits are not determined for the European collectivity and not on a particular operator or generator profitability. So we assess the impact of interconnections and flexibilities for the whole European collectivity and not for one actor.
Thank you for that answer. So the next question, will the second window for providing a project in TYNDP be opened after the system needs study from Lubos Samseli? So I'm going to answer that one. In the past, in at least the previous edition of the TYNDP, we had two windows for project selection. One window, the first one, were for the projects which were already mature, which had been in the TYNDP in the past. That allowed us to start working ahead in our project and to be sure to deliver the TYNDP on time. Then the system needs study was released, showing where future investments could be needed. And the theory was that with this study, we could open a second window for new projects that correspond to what we had found. This is something we did mostly on the advice of stakeholders, including regulators. The lesson learned from that particular experience was not so great. It actually created confusion for the project promoters, so we backtracked. And actually, as I said before, we consider that the study that was released in the previous TYNDP is accurate. The TYNDP 2020 was released about a year ago. And the system needs study that you can find in it really points for the next edition of the TYNDP. In terms of studies in the scientific world, 1 year is nothing, and the study is fresh and good. So no, that's not something we will do. We think that project promoters should be looking at one TYNDP to think about and design projects for the next TYNDP. National trend scenario will quickly become redundant as countries increase climate ambition. Should the analysis be repeated for more ambitious scenarios? Mamadou or Arthur, do you want to take that one too?
Well, I would say that as countries increase their climate ambition, we actually have new national trend scenarios from 1 year to another. So should the analysis be repeated for more ambitious scenarios? I would say that regarding TYNDP 2020 and what we have in TYNDP 2022, it is the case. We are repeating the analysis on a scenario that might seem more ambitious in terms of renewable development. So I would say for the moment, the issue is that each scenario we do the analysis on takes time and resources that takes too much time and too much resources. And scenarios are more ambitious from a year to another.
Yeah, so that's how we do it. I mean, we work in Europe with member states in which our TSOs are comprised with the stakeholders. So we try to get a view at a certain moment, and then 2 years later, things have changed. So now we speak much more about hydrogen. The offshore strategy is much more determined than it was even 2 years ago. So these are examples of things that have evolved for everyone in the energy sector, not only us. So the next question, REST and hydro time series have a great impact on this study. That is true. Will you consult them? 2040 REST time series were not published nor consulted in the previous system needs. Yes, that's a quite a specific question. So Mamadou, go ahead.
About that, yeah, of course. The hydro time series and the rest of the ones, of course, they are very important on the study, the result, etc. They come from the model, the market models built by ENTSO-E, using all the PMDBs, etc. So I don't know if it will be possible to publish them, but so for that I don't have the answer. Maybe Jean-Baptiste, you could complete. But we have them. They are available, and I didn't have in mind that that could be on a request. So maybe that was the reason why we didn't publish anything or try to consult on that.
Yes, so thank you for that answer. So sometimes we are limited in releasing data, and this is usually when either we are using private data, which we paid for, and which anybody can pay for. So for instance, that's the case of the climate data that we use. So this is, we are not allowed to share it because it doesn't belong to us. Sometimes the regulation is also stopping us from releasing some data. That's the case, for instance, of our network models, where we have to insert a dose of blurriness before we are allowed to release them. If it is the case that you would be interested in some data that you cannot find, you are always welcome to contact us at the Secretariat at ENTSO-E. You will find the contact on our website. It's TYNDP@entso-e.eu. You will reach our team directly, and we will answer to you directly if we can or we cannot share. And as Mamadou said, we cannot publish everything we have. We simply have too much things that would be really flooding you and recipients with data. We don't think it's helpful. So if there is something that you don't find, don't hesitate to ask. Sometimes it's just because we didn't assume someone wanted to use this data, and we'll be happy to share them. But at least we will answer to you if we can or not. So don't hesitate if you would like to use our work. The next question is also quite related to that. It's about the open data. So are we going to release our zonal clustered model with open data to allow complementary research work? Mamadou, I don't know if you want to answer that one.
Yeah, yes. In fact, in the Aeration report, we have published the clustering we used last time. It was the European zonal model using the identification, and so we have already published the clustering used. There were also not the details about which line is in which interzone, but for example, you can see in how much zones each country is divided, etc. So if you wanna run deeper analysis in your TSO, etc., we can discuss it further, of course, after Aeration on the how which are the lines which are in each clustering. So that the clustering we thought could be helpful for everybody. It was published, but not for the details. As Jean-Baptiste said, sometimes it's just because we don't have any requests. So if you need further, maybe we can provide, but maybe not in open data, because that is not helpful for everybody.
Yeah, and this being said, really, I like to insist, if you would like to work with our data, to do further studies with our data, contact us directly, do contact us directly. We can help. We have been working in the past with different entities to look further at that. For instance, the open modeling community, with whom we have discussed about, yeah, including the copyright labels that we should use. But don't hesitate to contact us. We are really happy and looking forward to hearing from people who are using our data, and to see how we can be more helpful. Will there be an option to deselect receiving a CBA for projects like it was possible last time for projects under construction? A question from Antje. So this is not a question I can answer right now. We will see what the steering group of the TYNDP decides. The question is specifically about projects under construction. It's a very specific point because these projects may or may not be PCI candidates and actually are already decided. For other projects, I can already say that all C projects submitted to the TYNDP will receive a CBA. There will not be an option to refuse the CBA, for instance, if you are too much in the future, like it might have been in past editions. So now we consider that if you are a candidate, you receive a CBA. So there might be an exception for projects under construction, but we will see that later. How is the investment candidate list developed and set? So I will answer to that as well, because it's really a matter of process of the way we are organized. So we are taking this responsibility very seriously. We have published selection guidelines, so a set of rules for projects who wanted to apply. Projects are currently applying. I think they have just a couple of hours to finish their application. Once this is done, we are going to review what we have received, and the selection guidelines is actually very clear about how we are going to do that. We are going to contact projects that are missing some information. We are going to review individually each project submission to speak with the promoters. Our objective is not to create an overly bureaucratic process. Our objective is to help real projects get into the TYNDP. So we will just speak with everyone to make sure that their contribution fits with what is requested, so that the study is fair, non-discriminatory, and informative. This is mostly done actually from the ENTSO-E Secretariat. The reason for that is many ENTSO-E members also are candidates, even though we really make a lot of efforts to separate these roles. And then the list of projects. So once we review, we have criteria. We just assess the selection once they are complete and clean with this criteria. If the project matches the criteria, they are in. If they are not, they are out. And we have also a process in place where people can appeal. We, of course, review, and regulators review the list of projects, and they can give us comments on projects that we have selected or eliminated. The next question will be for you, Mamadou, or you, Arthur. How is the location of possible flex solution identified?
Well, I'll go. On that point, there is, as we said, there are two kind of projects. There would be the realistic ones, and those were chosen because they are part of the previous TYNDP, of the previous TYNDPs, and there are the conceptual projects or trajectories, and for those we've decided not to discriminate any location and to let the optimizer choose where to install to build flexibility solutions. Therefore, there are candidates everywhere within the ENTSO-E countries.
Thank you. The next question is also about actually new types of flexibility. So the question from Robert Gordon-Mark, smart technologies can increase transmission capacity and can be deployed faster than new build transmission. So the non-wire solution, how do studies take their benefits into account?
In fact, about that point, everything depends on the candidates which we have. So if TSOs have some smart solutions which will help increase the transmission capacity on each border, so they have the detail, but they can provide the candidates in form of transmission one, and we will test it And if the candidate is selected in the needs, we can see the benefit of having this kind of candidates included in the grid system. So in terms of study, we do not define the candidates. The candidates as our input for the study, which we obtain by collecting them from TSOs and project promoters.
Thank you. Yeah, and once again, I mean, I really think that this is the concept of our study. We are really looking at proving that solutions exist, and then it's also for the market to figure out which is the most effective solution. And sometimes it must be wires, and very often we need all of them. So we need infrastructure where it is needed. I mean, there is such a huge amount of cables to pull. No one is going to argue against any non-wire solution. It is going to be a huge challenge for Europe to develop a system that can be decarbonized, and all of these solutions need to come out together. There are two questions or remarks by Mark Howick from Store Electric, so maybe we'll take them together. The first one is that the system needs definition omits stability based on real inertia, not synthetic, and skates over the worst case scenarios like the famous kalte Dunkelflaute. So what happens in these cases? I'll give the floor to you, Mamadou, but maybe first I will just look at the second question. Inadequate calculations of trade-offs need to triple the grid size for renewables. So if you can lower the screen so I see the end of the question. Unless sufficient well-located large-scale long-duration inertial storage. So this is also not a question but a remark, and actually this is at least part of it, I definitely agree with, not necessarily with the fact that we have an inadequate calculation of trade-offs, but of course about the fact that there might be other better, more effective or cheaper solutions that need to be explored. And when we saw into the first presentation that was given to you by Patricia Labra, the projected capacity that needed to be increased, once again, this just proves that this delivers benefit for Europeans. But if market can come with a solution that delivers the same services, so that fluidifies exchanges of electricity between zones or brings flexibility at a cheaper cost, then this is what will happen. And for sure, I mean, yeah. Mamadou, you can take the other part of the question, the one on inertia. Or
yes, the one on inertia and stability. There is a part of the Aeration report which treats the question. So, but it is separately analyzed by from our study. So our study only focuses on the transmission system capacity, etc. So, but there are some other items which are treated, and there will be something published normally in the reports about the stability studies in European.
And the kalte Dunkelflaute was a specific point in the question. So how do we address these extreme cases? Do we take extreme cases like that into account in our analysis?
In fact, yeah, go ahead, Arthur.
Thank you. The idea of using multiple, there are 2 points here. First, the idea of using multiple climate years, as we said in IOSN 2040 and hopefully in IOSN 2030, because those climate years are chosen on a statistical basis in order to take into account and represent all possible or as much as possible, all type of years, including cold years and very cold years like Dunkelflaute with a low wind. So this is taken into account into climatic years.
Thank you very much. So maybe we are going to take one final question. Or I see. Okay, maybe we will conclude. I see so two more questions here. The first one is about what we are going to release and the amount of data that we are going to release. And the second one is a response to my remark that 2050 was too difficult, so I haven't been able to read it yet. Mamadou or Arthur, do you want to take the question about releasing the standard costs and all of the data?
Costs are already published normally. In the previous TYNDP, there was something on that point. So the candidates, the cost, the capacities, etc., everything was on the appendix of the report.
Yes, so yeah, thank you for that. And once again, so if you would like us to release a specific data or you have advice about what should be useful for you, don't hesitate to tell us, mostly through the consultation. That's the most useful. We are really willing to hear that, to hear how people use our data and what is useful for them so that we can put online the most appropriate things. We can conclude.
In the previous TYNDP, it was published from Appendix 2, page 36 and 37. Normally, if you want to check.
Know where to look now. I can't tell you yet the page number next time, but for sure we will release the standard cost. So the last point, so by Mark Howitt, disagrees that 2050 is too difficult. 2050 is what we need to be decarbonizing. 2030, just 8 years, is an extrapolation of current plans, totally different approach. So I agree with the second part of what you're saying. 2030 is just 8 years from now. It is indeed really, really close in terms of development. As I mentioned, the main people who are interested into that part of the study are going to be the regulators, the policymakers, the people who have to take no regret decisions. Of course, they should be informed by the cost-benefit analysis, but looking at the impact of an overall collection of infrastructure and looking at being able to prove that there is a version of the system that is going to provide very substantial benefits for these investments is also something that is useful for the PCI process, but not only. So that's why we also perform 2030. We see 2040 for us, that's the right time horizon, not because we think that everything will be delivered by 2040. I don't know if we have to decarbonize 2050. I think we have to decarbonize right now. Climate change is right here and we have to put all of the efforts. 2040 for us, it works in terms of getting results that are meaningful with the reality also of our studies, which are technical modeling studies. So we are not just, I mean, we need to be able to get scenarios that are sound, that work technically to test the infrastructure, and by 2050 I think the uncertainty would be too big. This being said, of course we are looking at 2050 and we aim at well soon starting developing the models for that time horizon, so it will come on the table sooner than later. It is 2 minutes past 12. Thank you very much to all of you. Thank you very much for contributing so actively to the questions. I'm very happy that we had so many questions. It's the first time that we organize a webinar like that where we were just speaking about methodology, not showing any results. We were internally wondering if there would be a big interest from the audience, and the answer is that there is, so we will do it again. Thank you for participating. Thank you to the contributors, to Patricia Labra who left, to Mamadou Lo and Arthur Burlin who have presented as well, and to all those who have contributed, to all those those who are also performing the study. To all of you who are still here, please tell us what you have to tell us. This is the way we are going to progress together. Tell us how you want to access our information. Tell us what you think is relevant. Tell us what you think we should be exploring in the future. And if you don't do it, we will be less good. So looking forward to getting all of that and to seeing you again for the next webinar when we do have results to show to you. Maybe Leah, give you back the floor for the conclusions and the next steps.
Yeah, so just to close, as you can see on the screen now, we have another upcoming webinar already next week, because right now a very important consultation is ongoing. It's the consultation on the TYNDP 2022 scenarios, which were published, I think, last week. So if you're interested in the iOS and TYNDP in general, please don't hesitate to check out the scenarios. The consultation will end on the 18th of November, and if you will use this QR code, you will land on the consultation page. Apart from that, thank you very much also from my side for all your questions and comments. If you have more questions, don't hesitate to contact us at tyndp.entso.eu, and we'll make sure to reply to your emails. That's all from us. I will close this webinar now.
Thank you, and thank you to you, Leah, and to you, Ilaria, for supporting and organizing that webinar.
Thank you.